video channel so that you can keep track of these recordings on my YouTube channel. So the recordings will be available in both the recording will be available in both YouTube. So you can keep track on YouTube, and also they will be available on Zoom. Okay, let me minimize this.
Professor?
Yes.
I'm sorry, did you say that quizzes are taken during the lecture or at our
Yeah,
own
the quizzes will be during the lecture. There will be 15-20 minutes online using Canvas, and that this will allow you to ask any questions about the quiz, that you might have about a particular question in the quiz. But if you do need to have the quiz perhaps a little later or a little earlier because you are halfway across the world, and it's not reasonable for you to wake up at 2 in the morning to take the quiz, we will certainly work with you. But most folks are within reasonable time zones, and especially in this section that has been scheduled for this specific time and day. So yeah, so let me know if you need special accommodations. Also, another thing, all these videos, all these lectures will be recorded and made available so that you can view them at a later time. But the expectations is that you watch the videos at the earliest available time, right? So don't wait maybe to the end of the week where you have maybe 2 or 3 lectures backed up that you haven't watched just yet, and then you do a binge, you binge watch all the lectures, right? The intention is that they are recorded for your convenience, so that you can view them later, so that you don't have to, you're not required to be here live at the lecture, but you should watch it maybe later in the same day or perhaps the following day, right? There will be some time-sensitive information and announcements during lecture time, and even though you're not watching it live, you're still responsible for any time-sensitive messages, any time-sensitive announcements that we make during the lecture. Okay, the time sensitiveness will be with enough anticipation that you will know that perhaps next week something will happen, or that we have maybe moved a quiz to a later time, and things like that. Okay. Do we have to complete the quiz and attend the class? Yes, the intention is for you to be during the quiz and at least take the quiz, at least be here to take the quiz. It will be at the beginning of the class. It'll be made available for the first 15-20 minutes. You can take the quiz, and if you don't want to stay, you can certainly come back later and watch the lecture later. Okay. Yeah, the intention is that you take the quiz live with the rest of the class. Again, if there's an edge case or some reasonable reason why you cannot be here, again because of time constraints or your particular zip code or wherever a geographic area that you're in, let me know, and then we can work with you to deal with those edge cases. Okay. Okay. Let's see. Grades. So grades are going to be available here. So you should be able to see all the grades for each one of the assignments and the quizzes over here. Okay. All right. So let's take a look at the syllabus. So if you go to the syllabus, let's see. So yeah. So at the top of the syllabus, you'll have links to join the 2 very different sections that are available for this course. You have section 1 and section 2. They're both on Mondays and Wednesdays. This lecture is between 2:50 and 4:30, whereas the one that follows is at 7:30 to 9. And again, these two links allow you to join either one. For Piazza, there's the link that takes you to Piazza, again, for any questions about the assignments or quizzes or any feedback or even private messages to myself or the TAs, please use Piazza. Okay, Piazza allows you to post anonymously or privately, so you don't have to share with the rest of the class. So please, let's use a single form of communication. Although I will share my phone with all of you. And please, since it will be my personal phone number, please don't share it with anyone else. I don't know, I suddenly have started to have a lot of anonymous calls or in a lot of spam. Hopefully folks are not sharing my phone number with out there. We have office hours. Have office hours on Tuesdays and Thursdays from 7:30 to 9. And if you want to join my office hours, here's the Zoom link. Right. Also, the TAs have their Zoom office hours at different days and times, and these are their Zooms if you want to chat with them. Okay. And again, please, we've tried to spread out the TAs across the whole week at different times so that it's convenient. Hopefully, there's some convenient time for you to be able to discuss any issues that you might have. The goal of the course is for you to become a web developer, and feel comfortable at the different layers of a web application. How are office hours set up? Do we sit in the waiting room? Yes, usually myself and the TAs will have a waiting room. What I tend to do is I allow everybody to join all at once, but I do ask everybody to make a right when they join, right at the chat, to make a queue, to see who came first, and so that I can help folks in a particular order. So once you join, in the chat, please type in your name, and so that we'll know that you are next. And yes, all times are Eastern time. One of the reasons why I let everybody join is that one of the problems that you might be facing might be common to everybody else, so that all the folks can listen in on those solutions, and so that maybe they'll have their questions answered, right? So that if they see somebody have something solved and says, "Ooh, that applies to myself," perhaps I can help more than one person at a time. Yeah, so the intention of the course is to make you into a full stack engineer, right? That it's not only focused on the front end, it's not only focused on the back end. We tackle the entire the different tiers of a web application, right? We will start with tackling the front end, starting today. We'll use HTML and CSS to create a user interface. And as we progress and learn more about a particular technology, we'll introduce then JavaScript as a means of being able to control the behavior and interact with the user as they click and drag and move the mouse around. And then we'll introduce React as a mechanism for displaying content dynamically on the client, on the browser. And then we'll introduce, halfway through the semester, we'll introduce how to interact with a remote server and also a remote database. So first, we'll talk about a relational database, MySQL, but then we'll introduce Mongo as a non-relational database that can do similar things. Okay, and also Node.js in there somewhere as well. Each assignment builds on the next. So the first 4 or 5 assignments, they all build on the previous one, right? And so what will you be doing is that you'll be creating a Git repository for a specific technology, and as you progress throughout the semester, you're going to be adding to the code base of that code repository, right? And now we'll need several code repositories based on the different technologies that we're going to be looking at, right? So for the front end, we'll have a repository for React.js. For the back end, we'll have a repository for Java, and these and the code bases will interact with one another, as the front end makes requests from the back end, right, for data so that it can be rendered on the front end. But yeah, so we'll be managing multiple code bases, right, for different technologies that will combine, right, and collaborate, right, to build an entire application, right. Here's the agenda. The agenda, here's Monday. So we meet Monday. There was no class for MLK. And today we are introducing the course. We'll get you going with the first assignment, which won't be due until February 1st. Okay. And so we'll get you going with some basic technologies such as HTML, CSS, getting started with the setting up the development environment, and starting to code some web pages that allow you to do some basic features such as being able to log in, register, being able to see some of the main pages that we're going to be working throughout the semester. This first assignment is we're creating a completely static page. It's not dynamic. It doesn't dynamically change over time. It's going to be static HTML pages that at some point later on, as we progress, we will make them dynamic. Right, all the data right now is going to be hard coded. But later on, as we introduce React.js and we introduce Java and databases and whatnot, those pages will become dynamic, right? We'll ask for data from the remote server, from the remote database, right? And the data that comes back, we'll use it to dynamically render the pages. But this first assignment is going to focus on implementing a little bit what folks in a real environment, in a real industrial setting, developers would create some kind of prototype, right? When folks are thinking of creating an application, they will usually create some prototype that is only the flesh, right? It's only the facade, right? Just the wireframe of these screens. That they look like they're finished, but they're not. Right? They're only used for users, end users, to take a look at it and get some feedback on, well, how do you like this? It allows you to check to see if the flow of the application is correct, whether buttons should be, if we should move a couple buttons around, if the layout of the page is correct, right? So we prototype this and to gather some feedback from the end user, right? So that's what we're going to be doing. The first assignment, we're going to be prototyping the application, creating a couple of static pages that you can navigate between them, but they don't actually do anything, right? They're mostly just static content. Later on, when we get into assignment number 2 and 3, we'll come back to these pages and we'll start making them dynamic, right? So yeah, so this first assignment it'll span about, let's see, it'll be due February 1st. So that should give you about a week and a half to work on that, and we'll get you started today. We'll do a lot of coding today as I demo the application and I demo the technology and the techniques, and then you can grab that content. And then you can continue finishing up the code on your own. Okay. Next week or even today we'll talk about styling as well, how to implement the user interface, how to make it responsive. We'll introduce both HTML, CSS, and Bootstrap. That will be the bulk material in this first week, this first week and a half, and so this will allow you to learn how to create static web pages. Week 3 is when we start discussing how to make pages dynamic. Right? We'll introduce JavaScript. JavaScript is the de facto programming language of the web, where you will be able to dynamically manipulate the content. Will today's lecture be sufficient for A1? I would say so. Yes, I think that there'll be plenty of material to get you started. So yeah, so definitely, at least the pages that we are going to cover today, I think for this assignment, we ask you to work on 5 different web pages, and we'll get you started on all of them. But today, probably we'll get you started on 3 of them, or maybe 2 of them, and the third, you basically can do the same thing as the first 2. And I'll tell you what how is it that you would complete, how would you continue on your own to finish those pages. Yeah. Are we allowed to create one repo called CSS and each tag we create separate? We will follow a naming convention for the repositories, and I'll create a repository for today, and you'll see what the naming convention should be. And because we do want to capture things such as your usernames on there, and make sure that it is a repository for this course. And so follow the naming conventions as much as we ask you to do. Okay.
Professor?
Yes.
Do you suggest doing code alongs during the lecture, or just kind of following you?
No, I would passively follow me, and then you can perhaps review the video and then do the code along. Because I'm going to be throwing at you a lot of concepts, a lot of whys that if you're busy looking down at your code and try to follow along and code as I go, you're going to miss out on the whys, right? You're gonna miss out on the conceptual part of it, right? Because I'm going to be coding, but then I'm also going to be talking about some of the conceptual reasons why we're doing it this way. And if you're busy looking down at source code, you're going to miss out on those best practices on that conceptual part.
And one more question: do we focus on unit testing at all in this class, or
no unit testing? No. Professor, can we use our personal GitHub account? Yes, you can use your personal. I would prefer they use your personal account since it's a little bit less restrictive than the university's GitHub repository. So definitely, I'll be using my personal one, and I encourage you all to use your personal one. Okay, so the third week, we're going to be introducing JavaScript and ES6 as a mechanism for programmatically adding behavior to your web pages and to dynamically manipulate the front end to generate dynamic content and retrieve data from a remote server and then dynamically render it here on your pages. And JavaScript is going to be very low level. Direct access to the DOM, and we'll talk about the limitations and the complexities of doing that, and why how that introduces the reason why you have libraries such as React.js. React.js is it's a little higher abstraction of JavaScript. If JavaScript is if JavaScript would be assembly language, then React.js would be C++, right? That introduces a lot of abstractions. Well, I think that's a little bit too much. I would say maybe if JavaScript would be C, then React.js would be C++, right? That it adds many different abstractions that are C++ adds ideas such as object orientation, inheritance, right? Things like that make you create more reusable code. And so same thing, React.js introduces a component-based way of thinking about building reusable components to build more complex websites, right? So React.js is also extremely popular right now, and so we're going to be using React.js for the whole semester. But we'll introduce it in week number 4. So we'll spend about a week and a half using React, just talking about React.js, and we'll see some of the not limitations, but some of the constraints and challenges of using React.js, especially for maintaining client state, and so we'll introduce a library called Redux that deals with some of those complexities, and I think you would say that it substitute one complexity for another complexity, but it's well worth it, right? It allows you to code in a functional way, allows you to remove state management at the component level, and allows you to break out of the front end part from the behavior part, right? Or maintaining the state part, right? So, and that makes your components much easier to test. Even though we're not looking at tests in this course, definitely it's very popular because it simplifies testing. We'll then week 7 we'll talk about how is it that we can interact with a remote server. Up to this point, up to week 6, you're going to be interacting with a server that I'm going to providing. Right, I'm going to provide a server that you can send data, retrieve data, you can store data there, and then you're going to be rendering that dynamic content using React and Redux and JavaScript. But on week 7, you're going to learn how to do that on your own. Right, you're going to we're going to introduce Java, and we'll discuss how is it that we can create Java servers that can talk REST, right? For creating RESTful web services that you can send JSON, you can retrieve JSON, you can add data and whatnot, right? So we'll learn how to do that. So week 8 is going to be about the first exam. On Monday, we will review all the material up to that point, which will include REST, Redux, React, JavaScript, HTML, CSS, right? And that would be for the first exam. And again, this exam is during class time, and so again, if for scheduling reasons or different time zones and whatnot, let me know and we can work with you. So that is during class, and it'll take the whole hour and a half. All right. So when we come back after that first exam, we'll up to that point, we won't have had any place where we're storing the data, right? So we will introduce a database-driven web applications where we're going to be storing data in a relational database. In this particular case, we'll be using MySQL. For those that have taken my database class, a lot of that what you've learned there about MySQL and using object relational mapping and whatnot, that totally translates to this over here. Are we allowed to add different technologies to the assignment, like cloud for practice? So you can add them for the projects. In the project, you're totally allowed to do whatever you want. Okay, you can use if you want to use Python, or you want to use Firebase, or you want to use any other technologies as alternative middle tiers or alternative relational databases. You're totally welcome to do that for the project. For the assignment, we do need you to follow the technologies that we have here, since we are grading this, and we have to have a standard way of making sure that everybody is graded equally. We're totally going to be using Postman for interacting with RESTful services to retrieve data, especially when we get to jQuery, right? And when we start talking about creating RESTful applications, we'll be using Postman for interacting with these JSON endpoints. Okay, so we'll spend about a week and a half talking about creating relational databases and how to store data and retrieve data and whatnot. Then we'll spend about a week and a half introducing Node, working with Node.js, and basically somewhat repeating what we did on week 7. Week 7, we're going to be using Java to create our RESTful services, but we're going to revisit that and use Node.js as an alternative mechanism or technology for creating RESTful services, right? So yeah, Node.js and Express JS, we're going to be using that for creating RESTful services. And then week 12, we're going to be spending about a week talking about using as an alternative database. We'll use Mongo as a non-relational database that allows to store raw JSON data that is very, very convenient for web applications that are consuming data already in JSON, right? JavaScript is would love to have the data already implemented in JSON, so that it can be easily iterate over that and represented in the front end. The last week is somewhat of a kind of like a buffer week. This, if we do need more time to tie a couple of loose ends, we can totally use week 13. But in general, my intention was to use that week for working on the project. Any questions you might have, any techniques that we might have missed that might be useful for your project, we definitely can cover it that last week. Week 14 on Monday, we won't have class because that's Patriots Day. There's no class there, and when we come back on Wednesday, that's the last week of this, that last class of the semester, and we'll use it for reviewing for the second exam, which will be scheduled for 5 days later, exam number 2. The project is going to be due also, I believe that Monday. Yes, that Monday also the project will be due on April 26th, the same day as the exam. It doesn't mean that you have to submit it on that day. You can submit it earlier. You can totally finish the project earlier so that you have time to work with your exams. You can schedule your and organize your way to make sure that you have enough time to complete the project and to have the exam. But we definitely need to have the project due by this date, right? Because then that leaves the TAs and myself a week to grade all the projects, because we have to have grades due by the 3rd of May, right? So all grades have to be in by 3rd of May, and then you'll have your grades in my Northeastern on the 4th, May 4th. Do we have makeup classes since we have 3 Mondays without classes? Okay, so, oh, you mean MLK? Wait, the semester did start yesterday, right? So it's not like we missed Monday. The semester did start on Tuesday, and the material is spread out, and I have plenty of material that I can share with you for that I'll make available those days that you can consume on your own. So for instance, like maintaining state on the server side, using cookies, using all sorts of techniques that definitely useful for your project. I can also share with you some prototype, how to create the prototype project that you can use as a starting code to get you going on the project. So definitely there's plenty of material that will be available, even those days that we're not gonna have any classes. So for evaluation, there's going to be about 8 assignments, and I say about as I want to give myself the capability and the choice of maybe adding an assignment or removing an assignment, and in that will depend on how how we're doing, how the majority of the class is going, or if I see everybody's on time, or if we're slipping a little bit, and so we can throttle on that. Also, same thing for the quizzes. There's about 6 quizzes, more or less spread out with the assignments. So right before the beginning of the next assignment, there usually will be a quiz. So before the A3, there will be quiz 1. Before A4, there will be quiz 2. Before A5, there will be quiz 3, and so on and so forth, right? And these are the technologies that will be on that particular quiz. Okay. Right, so the assignments are the bulk of the grade. It's about 40% of the grade. The quizzes is 10%. The projects is 30%. Midterm is 10. Well, this let me call it exam 1 and exam 2. So I don't want to say midterms and finals, right? I'd rather have them some vague names, say exam 1, exam 2. Late policies. So the late policy is very simple. If you need more time, if you think you're going to be late, you need maybe a couple of hours, that's fine. You don't have to ask for permission. Go ahead. What we'll basically do is that we'll grade your assignment, and if you were 2 hours late or 4 hours late, you lose 2 points or 4 points, right? 1 point for every hour that you are late. So there's no need to ask, if you can have another 10 hours, go ahead, work another 10 hours to finish it up. And, we'll just deduct 10 points from your final grade of that assignment. How are the quizzes different from the exams? So the quizzes are going to be very, very short. right? So you shouldn't need more than 15 to 20 minutes to complete the quiz at the beginning of the class, whereas the exam will take up the entire length of the lecture. Both of them are on Canvas, so both of them will have multiple choice, fill in the blanks. A lot of them will have kind of like puzzles, right? That you'll really need to understand how the technology works, right, to solve the puzzle. Okay. When would we expect to form a group and start our project? So yeah, I'm going to make the groups available soon, and you'll join that as soon as possible, and I would get started on the projects right away, right, and start talking to to your colleagues on what would you rather work on, and the teams. What we'll do is that if you go to your Canvas and you go to people, and if you go to project groups, in the project groups, there's going to be a whole bunch of groups in here, all right, listed as group 1, group 2, group 3, group 4, and so on and so forth. And then when I ask you to, you're going to, one of your team members is going to pick a group, randomly, and that has not already been claimed, because you'll be able to see, how many are in that group. So one of you goes into that group, claims it, joins that group, and they'll be the sole team member in that group, and then they'll tell the rest of the team members to go in and add themselves to that group, right? So that everybody now is in the same group. Okay. I'm not going to assign them. Only if there's any mistakes that maybe you joined the wrong group or things like that. I believe you can't. Once you join the group, you can't leave that group. Okay, you need either myself, the TA, to go in and fix that. So let us know if you need help on that. Can we only form groups with the students from our section? Yeah, somebody asked this earlier. So it's okay if if just a few teams here and there join other folks in the other team, in the other section. But in general, I would rather you stick to folks in the same section. Okay. The topics, you can choose any topic you want. There's going to be a set of minimum requirements for the project that are fairly generic. I hope that 80 to 90% of all of you will, the project will fit within those requirements. I think they're fairly generic, that they should be applicable to any application you can think of. But if you feel that you've come up with such a great idea that it goes beyond the scope of the or the requirements, we can totally work with you and perhaps negotiate one feature for another feature, and you can say, well, how about I don't do that feature that you're requesting, but instead I do this other feature. Okay, and if they're comparable in complexity, then we can totally accept that. So we can negotiate that. And I think perhaps 5 to 10% of you will make that choice, but I believe most of you will be creating a project that's within the requirements that I provide. Does the group creator accept join requests? No, you don't need to accept. Anybody can join any group. But at least one of you has to claim a particular group so that everybody else knows which one to join. And there'll be more of this as we progress and we work on those groups. Okay.
Can I ask a quick question? Are
yes, go ahead.
Project requirements already listed somewhere? Sometimes it helps to think about it as the semester goes on.
Oh yeah, certainly. We will go over the project requirements in the next lecture. I will share that. I'll send a link so you can take a look at it. Yep. All right, excellent. Let's see. Syllabus, late policy. What else? Submissions via Canvas, quizzes, 5 to 10 minutes long. Yeah, project. We'll show you that. Reading. There's no book. All the material that you need is will be provided for you within the lecture. Academic integrity, please refrain from cheating or copying or collaborating where it's not appropriate. A lot of this is being done remotely, so there's no way for us to to police you and make sure that you're not doing certain things. But we would expect that you to self police, and in an honor system. The TAs are very good at spotting code that might be too similar from someone else. Obviously, if it's code that we gave you, and we expect that everybody is using the same code base, then obviously that code won't be considered to be plagiarism. But if it's a portion of the code that we know this is yours and it should be yours, obviously if there's only one particular way of doing something, then obviously everybody's going to write more or less the same thing. But there've been cases where it's obvious that that some coincidences was not a coincidence at all. And so please make sure that you're not copying code from anybody. It's okay to take a look at somebody else's, what they're doing, and to discuss with your colleagues, in general terms. But certainly your work should be yours, right? Also, if you see some solution on Stack Overflow and it's just a couple of lines of code, that's fine. Just copy something real quick, and it'd be, if it's not necessarily pertinent to the to what's being graded, then it's fine to say, I got this from Stack Overflow, and give credit where credit is due. Just make sure that you're not trying to fool anybody, right? That it's not dishonest, and it's all in good faith, and give credit where credit is due, right? To give a reference on things that are relevant, or maybe it's a library that you found and you want to use that, and that's totally fine, right? As long as you're not trying to just show content as if it were yours, but it's not actually not, right? So please also, if you find code from previous semesters or projects from previous semesters, please abstain from copying or cloning or anything from previous semesters. Or if it's maybe a project that you worked on in a previous semester and you're trying to reuse that and not, right? So please ask. And usually if you have to ask, it's probably not a good idea to be doing it. So all right, I think that's it. Disabilities, if you have special needs, or you need some kind of special accommodation, please reach out to me. Let me know, and we certainly will work with you. If you need extra time on the exams or on the homework, let us know, and certainly we'll work with you. Okay. All right. Excellent. All right. Let's close that. All right. Excellent. Let's see. All right. Web development. Let me let's go over real quick web development. All right. So first of all, we are using an underlying fundamental technology called the internet, right? And real quick, any questions before we get started? Yeah, so a real quick introduction to web development, right? First of all, what is the internet, right? So we are using an underlying fundamental technology called the internet, which is basically a network of networks, right? A huge global network that connects many smaller networks together. That originally it was intended to survive World War III. Folks, were analyzing why, how was the U.S. able to beat the Germans, and well, lo and behold, we were able to just bomb the heck out of them and eliminate any possibility of communication. And we certainly didn't want to fall victims of the same the same fate, right? So DARPA and ARPANET, to develop ARPANET as a military solution for making sure that we didn't lose communication if we, that's something that could survive, extensive attacks. And this expanded to universities and research institutions, including at CERN, where that physicists were using the internet to share all sorts of of documents between them. And Tim Berners-Lee, looking at this as being so cumbersome that you have to use one piece of technology to share another piece of technology to create the content, and so on and so forth, says, hey, how about we marry all these technologies together? And and lo and behold, he invented the World Wide Web, right? Which is it's a combinations of HTTP servers, of browsers, and the standard for the communication standard HTTP, and the standard of writing your documents and using the HTML, the hypertext markup language, for creating ASCII documents that could be rendered nicely in a web page. So the combinations of these servers and these browsers, and being able to identify all this content through a uniform resource locator that identified each document on the nodes of the internet, gave birth to what we refer to today as the web. There was quite a few milestones throughout, where in the 60s the military developed the internet, that presumably was going to survive World War III, which never happened, but eventually made its way into a broader audience throughout the world, and it found their way to in the hands of the private sector, right? And the private sector commercialized it, and today is what we have from the result of the commercialization of what it was intended to be a weapon, is now it has created great amounts of progress and productivity throughout the world. So throughout the use of internet, we came up with different ways of organizing software and hardware, and we developed this architecture or topology of how computers can talk to one another or should talk to one another. One being a server that was responsible for keeping track of files that were shared amongst multiple folks that needed access to these files or resources, and then the clients who were the ones who needed those resources, right? So the clients would ask for a resource, and the server would return and provide or serve that resource to the clients. And today we still use this architecture, is widely used today. But certainly it was developed way back in the 70s. Eventually, computers became so small that they can live on your desktop, right? And everybody could own a personal computer. So this centralized client-server architecture eventually became very widespread, right, over the entire world, which gave birth to folks personally having a client browser, being able to access some remote machine. So we went from client server to personal to back to client server, since the World Wide Web is somewhat of an extension of the client server architecture, where now clients is basically the browser. The browser is the ultimate client, right, accessing a centralized server or cluster of servers that are being hosted by Amazons and the Apples and the Facebooks and the Twitters of the world, right? And now as folks built on top of this topology of this architecture, there were many different techniques and technologies that were developed specifically for building applications that use this infrastructure, right? And borrowing from techniques from legacy systems, right, that work nicely. If you massage those techniques a little bit, they became very relevant for building web applications. And today, we'll see that many of these of the technologies and techniques that we are very relevant today are based on, right, techniques and and technologies that were relevant, a decade ago, right? That have been massaged and repurposed for implementing web applications. Today, mobile computing and big data are, the main drivers of our industry, and who knows where we're going. Perhaps in the 20s, Elon Musk will introduce, Neuralink, and instead of having, a personal computer or laptop or tablet or phone, we'll have some personal thing embedded in our brains. Who knows? Meanwhile, in the last couple of decades or 3 decades, there have been a lot of evolution on what's been happening on the server side and on the client side. On the server side, when the World Wide Web just came out, all this content that Tim Berners-Lee was implementing was just static content. He wanted to use the World Wide Web to share research papers with his colleagues. He was writing papers on physics, and he just, the most dynamic things that he wanted was maybe just an image, and that's it. And so his documents were very static. And so folks, started looking at how is it that we can make them dynamic, right? So for instance, if I want to create a web page that is, changes over time depending on the time of day. For instance, I want to make a weather application, right? That shows me whether it's, the temperature and whether it's raining or snowing or whatnot, right? That page can't be static, right? I mean, it could be dynamic, as in a human being can go in and edit it by hand, but folks were looking to automate that somehow, right? So how can we programmatically make these pages dynamic and change over time as the conditions change? So the first solutions were that on the server side, we would instead of having a static ASCII file, an HTML file, we could instead generate it dynamically. We can generate that HTML dynamically, programmatically using C++ or Perl or some of those technologies, and we can do that dynamic. So that's the first attempt at doing that. This became very, very popular on how is it that we can best do this. PHP was became very, very successful at this technique of calculating the HTML, generating pages dynamically. Java 2 also became very, very popular as a mechanism for dynamic generation of content. Shortly after that, .NET as a competing technology and framework for doing this, but using Visual Basic, C++, ASPs, and whatnot, was an alternative competing technology that did the same thing. But most of these, what you have is on the server dynamically generating content, generating HTML dynamically. Okay. And all these technologies do the same thing, right? .NET, Ruby on Rails, Django, Node.js today, Python, Flask. These all follow that same technique. You dynamically generate the HTML. More recently, we have moved away from that technology. Instead of dynamically generating content on the back end on the server. Today, we are using mostly JavaScript on the browser side. On the client, we have their frameworks that allow us to generate this content dynamically, and they're all based on JavaScript that was initially created by Netscape in 95. And what they were trying to do back then, more than 2 decades ago, right? What they were trying to do is says, well, once you're trying to fill out a form in a web page, and you submit this form, and that data is going to go out to the server. The server is going to do all its manipulation and processing, blah blah blah. Well, how about before I even send it over to the server, maybe I could do some pre-processing and do some validation and maybe some messaging and let you know that data is not valid, or that emails doesn't work, or whatever. Whatever pre-processing that I could do before I bother the server with bad data, it'd be nice if I let you know and give you some feedback. So that became very, very popular, and technology such as Adobe, Dojo, jQuery took this idea of JavaScript and just built on that. It says, ooh, because not only can you do some really simple validation, you could literally render the entire page, not just a small form, right? But the entire page could be dynamically generated in the client, right, as opposed to the server, right? So many technologies started to come out, taking this idea. Certainly jQuery was one of the first ones. Then Knockout, Angular. Google came out with one of the more successful applications of this technique in the 2010, and then many others followed. Backbone, Ember, Sales, Meteor. There's tons and tons of technologies that follow this idea of dynamically generating the content, not on the server, but generating on the client. The server would provide the data, but the client would do all the rendering and logic on the front end. Google made a strategic blunder when they moved over to version 2, and they didn't make it backwards compatible to version 1. And a lot of the industry, moved away from Angular because they felt that all the code base that they had in version 1, it's kind of like starting all over, right? It's kind of throwaway and recreating all their applications from scratch. So they started looking at other competing technologies such as React. React.js became very, very popular, in 2014, 15. And today is one of the most successful and popular libraries for rendering content in the front end. And that's where we're going to be focusing most of our time. And today, Vue is also becoming very, very popular as well, and we can spend some time there as well. So the overall architecture that we're going to be, what is centralized? I vaguely remember something like Bitcoin is not centralized. Yes. So by centralized, I mean, like for instance, this server here, this server is providing some central control over an application, right? That it's usually either one or a handful of servers that provide some central control over the data flow and the logic and the services that are provided for the rest of the application. And the clients, there might be just a handful of servers, but there might be hundreds, thousands, millions of clients, right? Each one with their own browser, and all of them sending requests to a central server or servers, right? And usually these servers are beefy servers, right? That have very powerful machines, or a farm of these servers that can work in tandem. But the client, if we could push some of the work of rendering and processing to the clients, right, we can certainly distribute some of the work out to the clients, and that's what we're going to be doing, right? Instead of having the server handle all the front end and generating the dynamic content, instead the servers are going to be responsible for just providing data, right? And it's going to be the client's responsibility to take that data, right, and then render the dynamic content, right? So this is the architecture that we're going to be following. Now, it used to be that within that architecture, it used to be that users would go and access a web browser, requests for HTML, either static content or dynamic JSPs, PHP, Python, ASPs, right? It would execute on the server, and the server would provide a dynamic. It would calculate an HTML document, and then once it would be generated, it would send it over to the browser. The browser would interpret this HTML document as if it were static. Now, from the server's point of view, it was dynamic, right? And it would generate the HTML dynamically, but then it would provide the static ASCII file to the browser. And the browser's point of view, it was static, or static content. That was such an amazing rundown of how the tech came about. Okay, yeah. Now, this has been kind of, today, this is considered legacy technology. It's still widely used, and we will certainly use this technology, but a lot of what has been happening in the last decade or so is that we've been moving away from this. This still has its place in the web applications, but mostly today is the architecture looks a little bit like this. Instead of having the server do the rendering of the HTML, where we do the computation of what the HTML is going to look like, instead, the browser asks for a static HTML, static JavaScript. It comes down to the browser, and then the JavaScript executes on the browser. Right? The browser, the JavaScript has the loops, the for loops, the if statements. Has all the branching logic, right? And then it can manipulate the initial HTML template, right? And it can dynamically render content. If it needs data, it can go back to the server and ask for data, not for content, ask for raw JSON data, right, as arrays of objects, right? And those would come down, and then the browser would use that data to dynamically update the data. You know, and most websites that you see today out there use a combination of each, right? So usually the first page that you see will probably be using this technique, right, where we can very quickly, a very powerful server can calculate the first landing page, right? But then subsequent accesses to the page as maybe you interact with the cart, or you like something, or you thumbs down, thumbs up, or you add something to a playlist. And as you interact with the page, you know, as you browse, you know, content, or you drag a map, then you're using this technique, right, where it's JavaScript that is dynamically rendering your content. Okay, so yeah, we're going to be exploring both techniques here in class. All right, some of this stuff is more about engineering, and we can take a look at it a little later. I do want to get started with the first assignment. Let's take it. So first of all, any questions so far? All right, I do want to get you started on the first assignment, so let's take a look at that. Okay, so let's look at the first assignment. All right, so the first assignment is, again, you're going to have about a week and a half to work on this. And the intent here is to work on creating a prototype, a static HTML, CSS prototype of a couple of pages that are going to be the basis of an application that we're going to build throughout the semester. Okay, so all together, we're going to be building a project. Everybody's going to be building the same thing individually on your own, right? Obviously, with help from myself. And that application is going to be an online learning management system. Okay, something like Canvas. Right? If you go to Canvas, what you see is what you have a dashboard where you can see all the courses, right? You can create new courses. You can click on a course, right, and then navigate to that course. And once you're in that course, you can add new modules, right? You can once you add a module, you can add widgets to it, like a quiz, a file, a page, a text header. You can add number of different contents, right? And so it's a learning management system, and you have different modules here that you can add and remove or move around, right? And you can add then content on the right-hand side. Okay, so we're going to be building something like this. Obviously, nothing as sophisticated as this, but we're going to give it a shot. All right. So the first couple of pages that we're going to be asking you to build are the following. We're going to give you. We're going to be building some really simple pages at first. Like for instance, this a login page, right? That is responsive, and by responsive means that you know, depending on the size of the screen, it shrinks and moves around and changes from a layout, a horizontal layout to a vertical layout. The same page, the same screen, without going anywhere else, it adapts to the size of the screen. So that's what we mean by responsive. When you sign in, obviously there's not going to be an actual sign in, right? Because we would need code for that, right? We would need a server, we would need JavaScript. We don't have any of that. So this is going to be completely static, right? I can't stress enough. I know that I'm going to get a lot of questions on Piazza. Does this have to actually work? Do you have to actually sign in? No, right? This is all going to be static. This is all going to be fake, all right? Eventually, we're going to make this for real, right? So we're just going to work on the front end, on the look and feel and whatnot. It doesn't have to look like this. You can tweak the look and feel, maybe the colors, the fonts. You can choose that. And you're going to be creating a couple of pages, right? The HTML document that creates the login. We'll also give you some starting code here. This is only a representative code. You might as well use the code that I'm going to give you when we get to actually building this. And then you're going to work also on a sign up, so login and register page, right, where you can sign up. And you're going to work also on a profile page. The profile page is that once you log in and you're logged in, you can see some information about your account, right? Your username, your phone number, email, your role, whether you're faculty or student, right? Your date of birth, things like that, right? Eventually, this will be for real. For now, this is all fake, all right? This is all static, right? It doesn't change over time, right? You can't actually change anything, right? Even though it says update and log out, that's all fake, right? It's all static. It doesn't actually do that. Also, some of the controls we're going to learn about how to create drop downs, how to create date pickers. We're going to learn about emails, right? Things like that. Okay. All right. So that's we're going to be starting working today, right now. Later on Monday, we're gonna play around with creating this course manager. So this course manager is the equivalent of this dashboard on Canvas. On Canvas, you see a list of your courses, right? Me as a faculty, I have the courses that I'm teaching. You as a student, you might see the courses that you might be registered for. Okay, so this what I call the course manager is kind of like your dashboard, right? That I can see all the courses in a grid, in a tabular format. See that? It's in a table format. And me as a faculty, I can create a new course, right? You as a student cannot, right? But I can create a new course, and I have a plus sign to create a new course. Again, all this is static, right? So if I click on the plus sign, nothing actually works, right? And all this is static here as well. Now, if I click on a course, just like in Canvas, right? If I click on a course, I navigate to that course. So I can edit that course, yes, where I can add content, right? I can add a module, right? I can do things like that, right? So same thing here. If I click on a course, right, it navigates me to a course editor, right? And in this course editor on the left-hand side, I have modules. Again, this is all static, and I'm going to give you the starting code to get you going with this, okay? And the look and feel doesn't have to look like this. If you don't like that it's dark gray and it looks sad, you can totally use a different look and feel. Okay. So here are modules. If you click on modules, you would see lessons up here. If you click on a lesson, you would see different topics. And if you click on a topic, you would have different widgets down here, and you can add a widget. Okay. Again, everything's static, right? When you click on the plus, nothing actually happens, right? And so yeah, so let's get you started working on this. And you're going to submit this. All your code will be submitted through Git. All right. So let's get going. So first of all, we're going to be using a technology called Spring or Spring Boot to create our very first web application. Okay. So let's do that. Can you all see my terminal? All right, so from our terminal, I'm going to go into web dev, and I'm going to create a directory for 2021. So make directory 2021, and let's go in there. And in here, I'm going to create also another directory because this is going to be the spring semester. Let's go spring. And in here, there's two sections. So I believe you're section 3, and I have section 4. So I'm going to make directory for section 3, sorry. And here's where I'm going to create my first project, right? And I believe the command is spring init to create my project. And the name of the project, we're going to go with the naming convention as follows. It's going to be web dev, right? I'm going to put the term. This is spring 21, and then the section is 03, right? And this is going to be a Spring application, right? That's going to use a Java server. It's going to use Tomcat, right, to host my HTML, my CSS, all my content, right? So it's basically going to be a Java server, okay? So I'm going to that this is going to be a server, and later on we're going to create a server that is a Node.js server. So we want to be able to distinguish between the two servers. So I'm going to call this Java. Okay. Also, another thing I'm going to add here is that my username, right? So I'm going to put here Genunzi. All right. So if you could, please follow this naming convention. This will give us a lot of information of what semester, the user, whether it is a server, what type of server, right, and whatnot. And also, I'm going to add here a dependency. Dependencies is web. All right, it's done. I'm going to open this with my favorite IDE, and I would absolutely suggest that you use IntelliJ as your IDE. Don't bother with STS unless you really like Eclipse. Then go ahead and use STS. But I think IntelliJ is far superior. So when I say open under Genunzi, we're going to go to web dev. Did I just create 2021? Where am I? Genunzi web dev. Web dev. Oh, there it is. Web dev 2021, Spring 03. There it is. Let's say open. Okay. All right, excellent. All right, so the IntelliJ is parsing the project. There it is, parsing it, it's indexing the project. The reason you know that this is a Java server project is because there's a POM file in there. See that pom.xml? That says that this is a Maven project. And Maven is a tool for building and compiling and testing Java projects, right? And there it is. That's a POM tells me that this is a Maven project, stands for Project Object Model. Also, most of your code is going to be under source, under main, under Java. We'll be doing some work there. Not for now. That's later on, like halfway through the semester. We'll come back to this. For now, we're just going to be working with just our server hosting our static content. Okay. So the way we create static content is that under the main directory, we're going to create a new directory and say new directory, and this is the web app directory. It has to be called web app, right? It's a standard name, right? And under here, you can put your static content, right? So we'll ask you to create here an index file. So this will be index.html. This is a special name for a file, right? It means that it's the default file, right? So if you ask for the content of a directory, what you'll get is the index file, right? And like the name suggests, it's like the index in a book, right? It gives you access to the rest of what's in that folder. Okay, and in here we're going to say something like, div, and it says h1, welcome to web dev. Okay. All right, excellent. So let's save that, and notice that my IDE has already identified the how to run this application, and the way you run it is basically under here under Java. There's a demo application. You can run it by right-clicking on it and saying run the demo application, or notice that it's already has seen it as the entry point of this application. You can just run it from here. So you'll run it. It'll compile. It'll build the project. It will start the server, and it will deploy locally on your machine, right? And it will run a server listening at port 8080. You can see the code here. Notice that it's listening at port 8080. See that? So we know that the server is running and listening at port 8080. All right. So how do we access this? We go to a browser, any browser, right? And we just say localhost. Right? Localhost is our local machine. We know the server's running in our local machine, and it's listening at port 8080. And in there, we have index.html, index.html. .html. We can now, we can say HTML. There it is. There it is. So we are looking at that page. There we go. We have our very first web page, right? Again, it's static web page, but eventually we'll make this dynamic. Any questions?
Professor?
Yes.
Was that HTML skeleton, is that default with IntelliJ?
Yes, when you say that you want to create a new page, right? It creates a skeleton page with
awesome.
a minimum content.
Nice. Cool.
Right, and all HTML pages have a specific structure. They have a doc type HTML. They have an opening and closing tag, right, that declares this as the content as HTML, and it has two pieces of content. It has the head and the body. The head is for like meta information, like who's the author, when it was created, the title of the page, things like that. Whereas the main content, what's actually rendered by the browser, goes in the body. Okay. Now this div, we'll come back to that later. Basically, it creates vertical spacing, but it's completely optional. I didn't actually need it. And H1 is a header that says this should be bold, black, big. That is kind of like presenting some content. Okay. All right. So let's keep working here. The assignment asks you to create a login screen. Right, so let's do that. The login screen should look something like this. It has a kind of like a header here, a label, input field, button, and 2 hyperlinks. Right, so let's do that. Right, and a good convention is to create your content right inside of a directory that sort of describes the feature that you're working on. Right, so here in web app, we'll create a login directory. So we'll say login. It's the feature that I'm working on. And in here, we're going to create a page, an HTML page. Now, the naming that I'm going with is as follows, right? The naming is should give me a hint on the developer, what is this page all about? Right? So the first part of the name of the file says that is the login feature. The second part of the name tells me somewhat what the role of this file is, and by template means usually what it means is that it's content, right, that might be dynamic, and here's the starting HTML content that can then made dynamic a little later. Okay, also tells me that this is content that is being generated or lives or runs or is meant to be executed on the client side of a client server application. Okay, and later is what format is this content? It's formatted in HTML. This is a completely arbitrary naming convention, right, that I just made up. Okay, it's a good naming convention. I've seen it used, fairly often in industry, and it helps developers somewhat, place themselves on, what if I'm looking at a page, right, and it's hundreds and hundreds of pages. The name kind of gives me a clue on what it is that I'm doing. Okay, and it places me in the right place. Okay, so I'm going to go with that name. Copy and go with that name. And there it is. The title, a good title is login. And here, let's see, what do we do here? We want to have a somewhat like a big header. So we'll go with H1 that says sign in. And then it looks like we have some kind of label here, username. Oh, I did want to point out, say I do just a layout like this, right? Just to point out something. So we have sign in, we have username, and then we have maybe an input field, and you create input fields as follows. Input. Then you have a what is it? Password. Password. Or another input field. And then we have a button here that has a label sign in. So sign in, sign in. And then you have two hyperlinks under here, maybe a hyperlink here that says forgot password. And another hyperlink right next to it that says sign up. Okay. All right, so let's navigate to this. It's under login, and this is the name of the file. So we can navigate to it. We can say I don't want the index file. I want go into login. This slash here, that slash, by convention, that slash is now mapping to the content of this directory. Okay, so I can use the URL here, right, to navigate the content of this directory by providing the path and the file name that I want. And the server is going to go and fetch that file for me and then send it back to the browser, which is the client, right? So again, I'm following a client server architecture. So login, template, then client, then HTML. Oh, I think I forgot the directory login. So login. There we go. All right, so not exactly what I was expecting. The content seems to be there, but it's not laid out the way I was expecting it, right? So what's happening is that my browser is really ignoring all the spacing that I put in there. All the white spaces is being completely ignored, right? And that's a feature, not a problem. Instead, we use tags such as the ones we're using here to layout, to mark up, right? We mark up the content and say, and tell the browser how this content should be rendered, right? So for instance, I don't want sign in to be just plain text, right? Just like username, right, is also plain text. I want the sign in to be big and bold, right? like a header, right? So what we do is that we wrap the content with tags that tell the browser how to render that content, right? So if I save that and I go back and render, notice that now it's a big header in bold black letters, okay? Then this username and password, notice that it didn't add any spacing between the two. We can do it a couple of ways. One way is to use the div. The div, as I mentioned earlier, allows us to separate content vertically. Right, so we can use a div and say, okay, well, this is one vertical spacing. And if I render, notice that now username and the button and the input field are now in its own vertical spacing, right? It added vertical spacing. Okay, so same thing with the password. We want to separate this password with the buttons. So let's do that. So we'll use this div here. There we go. So that now adds again vertical spacing. And this sign in and the forgot, we might want to do same thing here. We might maybe use another div here, right? And between this, like that. And okay, so this is starting to look what we want to achieve. Okay. Another thing that we did here is that this was very cumbersome having to navigate here and type the whole thing, right? Ideally, what I'd like to be able to do is starting from the index page. Remember what is the index page? The index page allows me to give access to the rest of the application, to the rest of the website, right? So it'd be nice to list here all the content that I want you to make available to you. Okay, so let's go back to the index page and let's use it for what it was intended. What I'd like to be able to do here is give you a text, right? That if you interact with that text, it navigates you to the login screen. So maybe this might be called login screen. Okay. Instead of being this boring text that does nothing, we can create. Oh, it's Spring blah 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 blah. I think we can use, instead of Spring Boot is a framework that conveniently sets up a deployable. Yeah, excellent. Yes. Why only not? Yeah. Is a procedure same as Windows? Is it okay? CLI, is it okay? We prefer to make a Maven Spring Boot. Yes. Section 1 and 2. Do we need to host this assignment application in Heroku? Yes, this has to be hosted on Heroku. Are we allowed to use any UI library for assignment? Yes, I would suggest using Bootstrap, but no, you can use other libraries. All right, excellent, thank you. All right, so how do we provide this link to there? And the way we're going to do it is by wrapping this with a hyperlink. We're going to say you're going to be a hyperlink, okay, not just plain text, and you're going to be pointing, right? You're going to be referring, right? It's a hypertext reference, right, to the starting in the directory that you're in. Navigate down to login, and from there go to login template client.html. Okay. All right. So now if I go back and I refresh, notice that now it has this underline. It's bluish. Right. So if I click on it, I can now easily go back to sign in. Make sense? Right. And I can do something similar. And once I'm in the login, I can create maybe a hyperlink that takes me back to the home page, maybe, right, to the index page. So we'll call this the home page, right? So this is maybe the home page. We go back. This is our home page. We click on it. We can navigate elsewhere. Okay. All right. In the login, we might create another hyperlink that navigates us back, right, back to home. Go back into the index page. Okay, and what we might call this home. All right, and maybe put this in a separate div. So we refresh. Notice that now we can close. Now we can navigate between the two. See that? All right, awesome. All right, so this looks terrible. Looks really ugly. So what we're going to do is that we're going to bring in some styling libraries, right, that are going to allow us to make things look a little prettier. Okay, and then what we can do is that we're going to use a technology called CSS. CSS allows us to style and make things prettier. For instance, we can say that the style, right, of this sign-in, I don't want it to be just boring black, right? I can say that the color, I want it to be red, right? And there it is. I made it red. Okay. But this is very bad practice to apply style right on the element, and you should avoid it at all costs. Okay. A little better would be to have a tag where you can specify all sorts of styles, right? Then you name them. You say, I'm going to create a color, a red color, right, that has your style. And then I can apply this to anything I want to make red, right? And I can say, see this dot here? It says that I can apply it using a class. I can say class red color, right? And then I refresh, I can change, I can say, now I can apply that same styling to anybody who I want to make red. For instance, I can change my password and make it red. I can say class red color. Right. The benefit now is that I can reuse the same transformation and apply it to multiple places, right? Instead of having to define it in applying style everywhere, right? And I can later on I can refine it and I can change the color, I can make it bold, I can make it all sorts of things, and it applies across everybody who has that class, right? So notice that now this is red as well. Okay, or better yet. So this is a little better, but not quite as good, right? The best that you can do is to get a library that defines all sorts of really cool look and feels, right? That make it look things very stylish and very professional. And this is one of them. Right? We're going to copy that. And you can bring in an entire set of rules that make things look really pretty. Okay, and the way we're going to do that is by using the link. You can say link, go fetch me a style sheet, right? That has all sorts of really cool, beautiful styling, so that I don't have to come up with all these reds and blues and whatever, right? So I don't want to use this style. Instead, someone else already, a very professional artists came up with all these really, really cool things, right? So I'm not going to use this class. I'm not going to use these classes. Instead, I'm going to use classes that Bootstrap has defined for me. Okay, already we see some changes here. For instance, notice that the font has changed, right? I can wrap this whole thing in a single div, right? And give it some space, some margins to make it look a little prettier. So for instance, I can say class. I can apply classes that are defined by someone else, right? Such as container. Container is a nice one. There it is. So now notice that it's creating already some margins in between them, right? I can also apply to the input fields. I can apply a nice form control, right? And that makes it, notice that it takes up the entire width of the page, right? And it adds some rounded corners, and I can apply it to that another input field down here, like that. And it makes it also vertically spaced. The buttons I can also make pretty. The buttons I can say class button primary and button block. I can apply all sorts of classes and styling, right, that make up my button prettier, right? I take up the entire width of the page and bluish and a hover color. Okay, and so yeah, so we're going to be using a lot of this to get you going and provide you with sample code that get you started. I'm going to push this into a repository and I'm going to share with you so that you can go on and keep working on this. I will add a couple of other example code that you can use, for the to get you going on the sign up page and also on the profile page. All right, and look, and I'll share with you a little later. All right, any questions before we go?
Yeah, quick question. I noticed that there's a set of slides on Canvas on setting up the environment.
Yes.
Do you recommend that we install all of the requirements for the class now, or install anything that we need?
Yeah, you should only install what you need. Like for instance, we don't need Mongo. We don't need the databases yet. Okay, we do need Maven, right? We do need Spring. And but yeah, no, the databases we don't need. We don't need Node.js just yet. Okay, we'll need Node.js in a couple of weeks, and so yeah, only the minimum that you need. Basically, just Spring, Maven, Java, and Git.
Professor, a quick follow-up on that.
Yes, go ahead.
Yeah, so like I asked in the chat, it's much easier like to make a Spring project. You can just go inside IntelliJ and add Maven dependency and all that stuff. Is it necessary to, I mean, is it okay to just do it that way, or do you want us to like actually go and install it in the
yeah, you can use it IntelliJ as well to do it. Sure.
Okay, yeah, because that's just much easier,
Sure. Yeah. Go ahead.
Okay, perfect. Thank you.
Right, anything else? All right, folks, thank you. Remember, I have an office hour tomorrow at 7:30, and then again on Tuesday at 7:30, right? So if you want to chat then. All right, everyone, thank you.
Thanks, Professor. See you.
Thank you, Professor.
Thank you so much.
Bye, take care.
Thank you.
Thank you.
Thank you.
Bye.
Professor.
Take care.
Thank you, Professor.
Thank you.